Dead-Bytes. Welcome to our project that we are submitting for Stellar X Hex this season. So we have worked on Kale-Pool mining, which is a parallel processing mining infrastructure. When I got introduced to the project, I tried to farm kale, and the only thing I felt that was an obstacle was that I could only plant once per account, and on my machine that is so heavy in compute, I could completed the work in, let's say, 20 seconds, and rest of the time my machine sits idle. So I thought, why cannot I work for other farmers who don't have such heavy machines? This is my basic problem, and I am working on it. So basically the kale mining protocol enforces strict per account limitations. We can plant, work and harvest once per every block. We are not breaking this protocol. Instead, we are having a shared mining ecosystem in which farmers that do not have high resource machines will hire a pooler or a worker, or you can say a worker, to work for them. So efficiency analysis, I did some efficiency analysis on my laptop, and these were my statistics. So the supply demand imbalance is clear here. Solution to this problem is that we initiate we initiate a smart contract between a farmer and a pooler, and all the rewards that are harvested by mining a block are shared in predetermined ratio between a farmer and a pooler. So our basic flow is that we have our backend service running, which is connected through REST API servers to the farmer interface and to the pooler infrastructure. Currently, I have deployed the pooler infrastructure locally on my backend, and farmer interface is public to all. Through our dashboard, farmer can register, and on registration, we will provide a custodial wallet so that we can uh, plant on behalf of farmer. And follows that we have deployed a backend service, a farmer interface, and a pooler infrastructure. Pooler infrastructure is deployed on my machine, backend is deployed on my machine, while public interface we have deployed on cloud pages. Now, through our farmer interface, farmer can register. On register, we will provide them a custodial wallet so that we can plant on their behalf, and there is no security concerns there is no security concern of farmers' existing wallet. We also ask them the checkout wallet in which we can send their kale rewards to. So our custodial wallets will only hold kales until the farmer is active in a contract. When the farmer checkouts, we calculate their rewards and send the share to the farmer and other share to the pooler. The share is predetermined in the contract when the farmer initiates the contract. For more detailed architecture flow, let's head over to the detailed flow. This is our detailed flow. So when a farmer initiates a leave pool request, we coordinate through the pooler machine. We complete the work that is pending for the farmer, and through the split contract, we split the rewards between them. Also, we plant via custodial wallets, and every data regarding plantings and harvesting is shared in our PostgreSQL database, which is currently deployed on Railway. Now heading back to our system, we have a backend API, that is this repository, a pooler client. Pooler client is in the separate repository, and our front-end dashboard. Intelligently, we have selected to scale this system, and that's why when a pooler has multiple farmers connected, we have orchestrated a parallel plant flow. The complete flow for our architecture system is described here. The pooler machine monitors the blockchain for finding new blocks on the blockchain. Whenever the pooler machine finds a new block, it notifies the backend API that this block is found. If that block is really new on the backend, then it asks the database to get the active farmers. When backend has the farmers, it initiates parallel plant flow. Here the stake is also predetermined as per the configs when the farmer joins the pool. After successful plantations, we notify the worker that these farmers have planted on this block successfully. Worker waits as per the config and then starts working. Working also happens parallelly, so even if multiple farmers are there, there will be some resource contention over the pooler machine. That's why we restrict pooler machine to not have farmers up to not have more farmers than they are capable to work on. Now we have auto harvest service. This is also parallelized. We have built a custom solution to the parallel harvester, which is different from the tractor SDK that Kale has built, but we have integrated the tractor SDK in our parallel harvester. This also harvests parallel blocks in parallel, but it also harvests parallel accounts. Let's head over to our landing page. So this is our dashboard that will show further in the demo. Currently, we only support joining as a farmer. Joining as a pool operator is in development right now, which we will develop in future. How Kale works, you have to join and set up your custodial wallet, fund that custodial wallet so we can cover the plant gas expenses. Join the pool that you are comfortable to join. There are different reward rates based on the supply and demand of the pools. We have the auto plantation workers, so once the contract is active and you are joined, you no need to worry and you can just sleep all day. Mining work is also coordinated very well between our backend and pooler system, and we harvest based on the farmer config. So let's head to our dashboard. You can see my custodial wallet address, my Kale balance, currently the blockchain block index, and my total staked Kale. You can see I have actively planted on the 81425 block. Here is the pool discovery, so let's join this pool. Let's have a harvest interval of 6 block and confirm joining. When our joining is confirmed, we have this my pool activated, reward split is there, and from here our work is done. The farmer has activated the contract. From here on, the work on the backend starts. Let's head over to the backend. This is the logs of our farmer and backend that are deployed currently. When a pooler discovers a new block, that is 81436, it notifies the backend. The backend receives the request for block discovered and scheduled a delayed planting so that we do not traffic the launch tube submissions. And after a while, the backend tries planting. On successful planting, the backend notifies the pooler that the planting has been done. This is our stake amount, which is calculated as per the contract. Then on schedule and received successful planting, we have scheduled the work execution. Currently we have registered one planted farmers. That's why we will only work for one farmer, and the work is successfully scheduled after some time. The work execution is scheduled successfully, log is written. After that, we need to submit our work to the smart contract. The Kale smart contract deployed. The work successfully completed and submitted to the smart contract. We have found five zeros and nonce was this. We can also see the transaction through the transaction hash. Also now the new block has been discovered, that is 81437. The backend has successfully planted on this. The pooler has received the notification and the work is scheduled successfully. Now let's go over to the dashboard and see whether these logs are there. Let's refresh our dashboard. And you can see that we have planted for 81437, 81436, 81434. Our harvest flow is completely empty right now as we have not harvested yet, but this shows that our system is working. And in future we are trying to collaborate with our second project, that is WeatherX Scale. For more details, please hand over to that YouTube video.